Good afternoon, everyone, and welcome to today's AFS Members Only webinar on Humtown's journey to serial production and how we went together, sponsored by Humtown Products. Before we begin, I have a couple short housekeeping items. Today's webinar will be recorded and made available to today's attendees. You will receive an email with a link to recording in just a few days. Second, our presenter today, Brandon Lamoncha, will be answering questions throughout the session. To ask a question, click on the Q&A at the menu at the top of your screen. A window will pop up for you to type in your question. You can type in a question at any time during this webinar. And now let me introduce you our speaker today. Brandon Lamoncha is the account manager / project manager at Humtown Products. Brandon has worked with Humtown Products for over 17 years, and he has facilitated in many areas of the company. Starting as a computer-aided machinist, Brandon learned how to produce tooling for aerospace, engine components, glass molds, and other foundry products. His attention to detail on these complex projects aided in his progression through the company to project manager and finally into account manager of strategic accounts. Thank you all for joining us today. So now passing this off to Brandon.
All right, thanks, Bo. Hope everyone's having a great afternoon. Can everybody hear me? Bo, you sound good?
Yes.
All right. Yeah, so thanks for joining us today. I wanted to take a little bit of time this afternoon, and if you're listening to the recording, thanks for registering to get that recording. It's good, to have this to go back to. So anyways, like I said, today we want to talk a little bit about our journey. Many foundries, many pattern shops, many companies in the metal casting industry are along a journey right now, understanding additive manufacturing and how it comes into play for their organization, whether they're a metal caster, whether they're a supplier to the industry. And, we all are winning together here in the U.S. and the Americas, with companies in North America, South America. We're all learning about how, this technology is advancing, our foundry base, and how we can be strategic suppliers to OEMs, how we can be strategic, to the government, the Department of Defense, and using additive manufacturing is a tool in that toolbox. So today we're going to go through. I told Bo, like he said, if you have questions, pop them in, as we go. He's going to interrupt me at the end of the slide or whenever it makes sense, and I'm going to try to answer as we go. That way, we don't get all the way to the end. And, if we need to have some answers, I'd like to get those to you, while you're thinking of it. So like I said, put those Q&A in and he'll interrupt me and we will get those answered right away so that we don't have to, remember everything at the end of our time together. So as Bo said, I've been with Humtown. My grandfather started the company in 1959 as a pattern shop. I started gluing up segments and, for wood patterns and, learned how to do everything conventionally and then started getting into CNC. So I have a good understanding of tooling. And that led me to some project management, sales manager, and now I'm currently the director of additive manufacturing. Humtown, for those of you that don't know who we are, we started out, as I mentioned, as a pattern shop in that little building at the back of that house in 1959 as a pattern shop. My grandfather and one other gentleman, said that they wanted to go out and start making patterns. The place where they previously were employed, they wouldn't let them talk from the time they started in the morning till the time they left, and they didn't like that. So they started their own pattern shop to serving local foundries. We had a very foundry dense region, and patterns, as are well needed in our area. So and what you see here to the left a little bit, that building, that was our pattern shop. That's where we had our CNC machines. And in the 70s, my father saw the need for commercial core making. There was two bottlenecks in the foundry, one being core making and the other one being casting grinding. And he didn't want to start a grinding room for obvious reasons. So started making cores. You see all the trailers up there. We would load trailers and we would ship, semi-loads of cores to foundries all throughout the Midwest, typically within a 500-mile radius, but sometimes further. I mean, we've shipped conventional cores all the way to Mexico for prototype projects. So that's who we were. We were a core manufacturer primarily. We still, we're making CNC patterns and hand patterns. We no longer do that. That building now is just a service shop. We keep our core boxes, running good and, changing out vents, cleaning them, et cetera. But we have no more CNC capabilities, and we'll talk a little bit about that in our journey. this is for many of those that haven't been into a commercial core room. This is a little bit what a core room. Well, video was working earlier. There we go. So this is our traditional facility. Many of you have core rooms in your foundries or you've been in them, but rows and rows of tooling. Every single geometry needs its own tool, which is obviously large investment. Sometimes Ren board, sometimes iron, sometimes aluminum boxes. But we have a central mixing station, where you mix the sand and put the binder in and send that off to each core machine. Has a magazine. This is a horizontal blower. The machine closes. The sand is blown in under air, and then the gas head comes over, and we use like dimethylethylamine gas to cure the cores. And you're able to produce a core rather quickly. Sometimes in less than a 1 minute cycle time. So this type of core making is still we make cores every single day at Humtown, just like you make in your foundries, and we supplement foundries on core supply, and it still works really, really well. For high volume. Today we'll talk a little bit about where we're transitioning 3D printed cores versus conventional, but that was our process for many, many years. When this all started, just like you on your journey, we are starting to look at what is additive manufacturing. We started this journey back in I don't know, about 10 years ago now. Started looking at it primarily for tooling, and as you see on the right, we have a core box here with some intricate loose pieces. Typically those would have been CNC machined, 3-4 axis machining, multiple setups, and very time consuming. So we started making stuff on a MakerBot and just tinkering around, seeing what could we do, how could we do it, what were some ways of process improvements for making tooling and inserts and loose pieces, and it worked really good. And then we jumped up to this Stratasys machine, which you see here, which was a very good piece of equipment, in its time. The consumable costs got to be really, really high, and they were kind of locking down their consumables. So we ended up pivoting to what you see here on the left. We saw, the additive manufacturing, the binder jet process versus the FDM, being able to actually skip the entire tooling phase and actually just jump right into 3D printed molds and cores that we could then supply to a foundry. They were able to take those molds and cores and literally pour a casting in days. So this really caught our attention. Back when we were just getting into this technology, there was only one pattern shop and a lot of OEMs and government entities and universities that had this piece of equipment. So we were very early on, 8-9 years ago, and but this is where the technology that we're going to talk about today. And this was, our journey to serial production. We no longer have the Stratasys. We no longer make tooling. Now we're all in binder jetting of silica sand and well, we'll talk about some of the other materials. But this is a little bit about us. We have two facilities, as I mentioned, one in Columbiana, one in Boardman. This is our third additive manufacturing facility. We'll talk about that journey and how that looks. Like I said, we're third generation, one of the largest 3D print service centers in the world. And, we serve industries, all across the spectrum. So early on in this journey, as many of you are looking at, either getting machines or maybe just getting your first or second printer, we saw that, there wasn't a huge adoption of additive manufacturing in the industry. I would go out and, we would purchase cores from X1 or one of the service providers, and, we would do the design, or we would find the application, and we would work with our local foundries and get it printed somewhere and then bring it in. And we saw the benefit of it right away. Hey, we don't have 8 to 10 weeks to make tooling. We can make highly complex cores. And what we wanted to do is we wanted to get more and more people understanding, that this technology exists, but we didn't know how to get the message out. So we approached America Makes. We were very fortunate to have one of the first innovation institutes placed right in Youngstown, Ohio, in our backyard. So we went to them with this dilemma. They were asking for project calls, and we said, hey, we want to use this technology more, but these assets are well over $1 million. We don't have the capital. We can't secure a loan. At that time, nobody would loan on this, bleeding edge, cutting edge technology. So we said, how do we go about this? So we put this project call in. We were assembled with a team Our team, it was incredible. We had obviously the AFS, we had some local foundries, some local pattern shops, some large OEMs like Caterpillar, resin and coating companies like Refcotech, and some really great partners like University of Northern Iowa, Youngstown State University, YBI, even the machine manufacturer X1. So we all came together and said, how do we solve this high overarching problem of getting this technology out to the masses? So got this project team together, started using the printer at the University of Northern Iowa, started developing ways to educate the industry. Actually, out of it, the AFS came like one of the first pocket handbooks of additive manufacturing. So just really good team came together to talk about this, and what it ended up doing was actually getting the first printer through Youngstown State University for another project call, and that's kind of how we got our footing in this technology. So team-based approach. We didn't know where to start, so we came together and used an organization like America Makes, AFS, to build this as a platform or a bedrock. So for some of you that may not understand what binder jet 3D printing is, no problem. Very simple process. We basically lay down a layer of activated sand. So we take silica sand, ceramic, carboceramic, some of the trade names, but ceramic or silica media. We mix it with an activator. That's all activated. It's all spread out on the bed. The print head comes along much like your inkjet printer at home. Instead of having HP ink in there, we actually have a binder, a Furan binder. There's other binders. We can talk about that later, but we primarily at Humtown, we are only using Furan at this time. Basically, the print head deposits that just like on a sheet of paper. It shows what it wants to print. What you see here, the green, that's actually being deposited. That's what's going to become the core or the mold, and then that's just that process repeats over and over again. 700 millimeters tall, and we typically do that at like a 0.28 millimeter layer thickness. So the job box takes roughly 18 to 20 hours to complete. We depowder it. All the white that you see is loose sand. We vacuum that away. You're left with the green, and that's your basically your core or mold. When we got into this, as I mentioned in 2014, these were the players in the space. If you wanted to buy molds at that time in the U.S., you basically had to either go to X1, the machine manufacturer, or Hoosier Pattern. That was pretty much your options. We started as Jerry Thiel at UNI put his first printer in at the university. I drove out there, met with Jerry. He was, had this technology, but he didn't have someone to actually go out into the industry. So I said, put me in, coach. So I started driving all over the country, printing molds and cores, and getting these cores and molds many times as samples or very low cost projects, getting them into foundries so that they could pour metal and get a casting and show their the people in their organization the value of additive manufacturing. Now, since that project and over the years, I need to update this. This slide was back in 2022, but several more. We know we have over 100 printers in North America, Mexico, Canada. They're all over. OEMs, universities, foundries, you name it. They're there. So this has been a really good, very quick adoption, I would say. Once we got the ball rolling, once we really got the ball rolling now, there's hardly any foundry I can go into now that hasn't used or seen a 3D printed core. And that's, some of the work that we've done, but also the suppliers in the industry, the Hoosiers, the Matthews, the other places that are in the OEM, the OEMs like Cummins and Emerson and Caterpillar have done a great job of putting these machines in and then showing, the industry what they're looking for from, the application for design, and we'll talk about that here in a little bit. But they've done a really good job of educating the industry of what they need, what they're looking for, and how to achieve it. So this was our first facility for 3D printing. We were maxed out where we were. We thought we were going to have a lot more engineering and design, and we only put one printer in through the help of Youngstown State University and the America Makes project. So we put that printer in the end of 2015, early 2016, and we started printing, and it was an incredible success. Or incredibly lucky, whichever way you want to look at it. But we had some customers that were really, really, pushing this technology, some OEMs. And basically that machine, we put that machine in, and literally from the time we started printing, it ran 24/7, 365. It was incredible. My father, myself, we would go in at 1 o'clock in the morning and clean the machine and get it flipped over to get the other job box in. It never stopped. And I think we still may possibly hold the record for a Furion printhead. I think that printhead had it was over double what the recommended, but it just ran. When you run these printheads and you run these printers, it had like twice the life expectancy. So I think we still hold the record, but either way, we were very fortunate, to get in at the right time where, these OEMs and customers were starting to really use their technology. So we put that machine in, and, it quickly was taken off. And, what were the benefits? What did we learn, by putting that first machine in? Why were we so successful or so lucky? Conventional tooling was taken at that time 12 weeks. Now, some tools I'm hearing pattern shops are out, 12, 14, 16, 18 weeks. You judge for yourself. Maybe you have your own pattern shop and you can get tooling in 12 weeks or maybe 8 weeks or maybe 4 weeks, and that's great. But what I'm hearing still is that, tooling, it takes a lot of weeks, 4 weeks, 6 weeks, 8 weeks. So we were able to do that, but we were also able to get a casting made using 3D printed sand, with the design, with the gating, with simulation, everything, inspection. We were getting a finished part to our customer, in less than 3 weeks. And what that did was, we were able to get that part to them, get it machined, get, for jigs and fixtures and setup, even in parallel, while they were making tooling. And then if there was any design changes or iterations that needed to be made, they could scan the casting and then they could make that change possibly before they even, finished cutting the tooling. So that was one of the biggest benefits that we were seeing at that time. New product introduction, prototyping, that was what was really, really taking off early on in the technology. Then we learned about, the benefit of consolidation of parts. And when we started taking core assemblies, and, taking 8 separate cores that, required 7 different blow cavities, whether that was 8 individual core boxes or, 1 or 2 or 3 family boxes to blow all those cores, then take those back to an assembly room with jigs, fixtures, glue, scrap, and then, think about taking that back and, this one core breaks and then you have to go back up to your production room, set up a core box, blow 20 more cores because they went scrap, in assembly. It was a nightmare. So this is the second sweet spot, but we are starting to see this now even overcome, the new product in the prototyping. And that's really what's getting, Humtown and a lot of these 3D printing companies into serial production. So I implore you to go through your foundry and, start and finishing, or, the core assembly room. If you're doing assemblies and it fits, in your hand, I can almost guarantee you, if we do a time study and a case study on it, this core was so much less expensive 3D printing versus doing it, the assembly. So once this started, taking off, it really started to grow, in our journey, and it really started to fill up, 3D printing machines. So, a lot of people, would say, oh, well, are you able to do large prints? And yes, the answer is yes. This is me. I stand about 6'4". That mold package, I think it was over 31 different prints, or 31 different pieces, between the outside mold, the cores, and it was pinned and bolted together. You can see the all thread and the bolts. But, this was made, I think it was over a 6,000 pound casting. So, at that time when we were doing NPI and, new, prototyping, we were starting to see a lot of use, with 3D printing, because imagine the tooling, that it would have taken to make all the internal cores. I know I can't show you, what the casting was, but you can imagine, this is a very large, intricate casting, and we had a lot of internal cores. And, to make all that tooling, it would have taken months. Whereas with 3D printing, we were able to get this mold package, within, 30 days, a lot of printing, but, we were able to get it to them. At that time, it was relatively quick. We had one printer with one job box at that point. Now, we have 12 printers in Ohio, and we were able to, we'd be able to print that pretty much in a week. All the different pieces and get them packed out and get them there. So, and this process is incredibly accurate. The machine manufacturers, promote plus or minus half a millimeter. We see that, a lot, and we've dialed it in on production jobs even tighter. So, as we're making this journey at Humtown, we're starting to learn more and more of the use cases. We're starting to see, okay, speed to market, great. Everybody can appreciate that, but that's just one, and then the core consolidation, okay, makes sense, great. But this was one that kind of crept up on us, as a necessity. We get this tooling in, and I'm sure many of your foundries, you get legacy tools passed down. This was for an aerospace part, and this is probably a 30 or 40-year-old tool. The platform was supposed to be retired, never was. We're still making service parts, and the tool was at end of life. And we went back and we said, hey, we need new tooling. They said, well, we can't get the budget for that. We don't have any files, we don't have any drawings. All the things I'm sure everybody on this call has heard at some point. Well, what we decided after about 3 or 4 days of trying to blow this core, using silicone and trying everything we could to create a chamber to blow a shape, we ended up deciding to just pour repro, scan it, got an STL file, and 3D print it. And we approached our customer. We told them, we said, basically, we're done trying to make tooling or make this tooling work. Here's your options. And they went to their company or their customer and showed them the option. They had to do, I'm sure they'd do a lot of testing and first article, whatever the case may be. But now the production method of this part is a 3D printed core, and it's working very, very well. So this was another use case. Like I said, as you are taking your journey, you're going to have different, but a lot of us, in this industry are going to have a very similar, journey in finding use cases for additive manufacturing. So if I can help you, in your foundry or, look at your OEMs have problems like this, lost tooling, damaged, worn tooling, additives can really be a solution to those, as well as some of the other obvious ones. Do a lot of hybrid projects now. 3D printing is still expensive. I'm sure there'll be some Q&A on that, and that's fine. That's what we're here to talk about. We're trying to solve those problems, with the machine manufacturers, et cetera. So what that's driven us to along this journey is, like, I thought we were going to do a lot of engineering and a lot of printing. So that beautiful office space, kind of sat, unused, because what we've seen is more and more of our foundries and OEM partners are doing a lot of the CAD and simulation themselves, and then sending us ready to print models. But they're also realizing that these molds can get pretty costly and pretty timely to produce. So if they can make a pattern, and just use the internal, shape of like this turbo housing to, produce the performance that they're looking for, that's what we're starting to see more and more of. And what this was a turbo. They wanted to change the internal performance of it, but the outside was still bolting up to the same engine. So there was no outside changes. They simply wanted to do a prototype of, this, reducing the cores by assembling them, less finish. They were able to eliminate backdraft and undercuts. We were able to print it. So they wanted to test this new design and use the same pattern. So what that's led us to is, a huge amount of our projects are using 3D printing in a hybrid manner, where you still would use your existing pattern. So this has been a great find, and this is a way that it's much more cost effective, for the companies and the customers, because they're not having to buy this whole 3D printed mold. They're using their traditional air set line. So this is much closer to their production cost. Another hybrid would have been this engine application. This was a 351 Cleveland block, and basically they wanted us to go ahead and make a different cooling channel. It was either overheating, or they were trying to push the performance, or thin wall. And we wouldn't have been able to blow this core conventionally. It had some really thin areas where we couldn't get wet, sticky sand to fluidize and get into those areas. But what he did was he made some modifications he poured a plug off of the existing box, made his modifications to the plug, scanned it, and now within a couple of days, and for a couple, maybe $100 for a set of cores, he was able to have a custom, I mean, obviously he did the design time, but in the CAD, but we did the printing, and I think it was like a couple, $100 or so for cores, and he had a custom one-off, 351 Cleveland block. So this is just another example of hybrid projects that would be very costly if you went the tooling route, if you could even blow it. But it was solved by additive manufacturing. And what are we seeing today in industrial applications? Now we're starting to see complex cores that can only be printed. So this was another gentleman had a cylinder head project. What he wanted to do, they were getting port-to-port variation. When they were assembling, the wall thicknesses weren't nominal. They were walking all over the place. So what he wanted to do is he wanted to fix the port and the jacket in one. Now for clean and getting in here and accessibility for cleaning, he did a really unique design where the port it mated, so you still had a little bit of an area and a little bit of an assembly. But we're getting better, and we're getting ways to get in and clean these packages. But for him, it really cemented in these ports to where they weren't moving, they weren't walking, because they were all printed in one monolithic core. You can even see he had some venting in here to directionalize some of the gas out the slab. It went down through the slab, and there were some vents. See venting here. So he was really taking advantage, and this is the type of designs that you would not be able to do with conventional core blowing. So that's what we're starting to see today. We have castings that cannot be made any other way than using 3D printed cores. They're made in a hybrid fashion where it's either a permanent, semi-permanent mold with a core that's 3D printed, or basically just this core, and then all the outside shape is made with your regular air set sand. But that's what we're starting to see today, and that's what's really pushing us and others into basically serial production, is because even if you could make a tool, and it doesn't matter how long, you still couldn't blow a core and be able to achieve the dimensional accuracy that we were able to achieve with 3D printing. So with that being said, what that's doing is that's taking additive manufacturing, and we look at it as a whole. Basically, investment. If you have any investment casting or knowledge, or in your operation, or they've been doing this for a while. They've been printing wax patterns essentially, or a PLA or whatever they're printing. They're dipping it in the slurry. They're burning it out. They've been doing this for a while. So we're not quite as advanced, or haven't been doing this as long as the investment cast folk. But we're catching. We've been in this long enough to see that. People now that haven't used this or adopted this technology, they're really in the late majority. I consider Humtown and some of the other people that were on that slide, we really got in the early market. I wouldn't say we were, developing the printers, we didn't come up with that idea, but we were in, that visionary, like, hey, there's something to this technology. There's a reason why these printers are there. And my Ford Motor Company was using them to develop things like the EcoBoost engine, making 4 different designs, and casting 20 different blocks and machining them and putting them on test engines, and then going to production with the one that performed the best. Like, there was a reason those were being built, and there was a lot of people were involved in our AFS additive manufacturing when it was an ad hoc, as it became a committee and a division. And I commend those leaders, and I commend people that are still jumping in and learning more and more about this. But we are definitely starting to see that more and more foundries and OEMs are using this, and we're getting into that late majority. We're starting to see articles like this. If you have your casting source on your desk, or read it online, Mercury Marine, they are using a foundry, Watry, that is producing a core or a casting in production, using 3D printed cores. So we're starting to see this really take to mainstream, and I believe I'm forgetting the article, but I mean it's several thousand engines per year. You know what I mean? This is not oh, they make 100 of these. This is for the Mercury Verado 600. This is for the lower power steering unit. The motor stays stationary, and the lower unit turns the prop. Very impressive. I think it was the first, and it's, to this day, I think it's still the largest, horsepower displacement engine available as an outboard. So very impressive. The technology, and I mean, you can imagine how precise, that would have to be, that casting, and using additive manufacturing for that core, help drive success. So thought that was really cool that was at the AFS honorable mention, and, they were able to share that story, because as more and more of you see this technology being deployed, and, and know that there's supply base out there to supply, you'll start using this, in your foundries, as a part of your technology, as a part of your solution set, to your OEMs, and you'll be supplying, OEMs like Mercury, like Ford, now that this technology is working. What we're starting to see, a lot of people, there was rumors of foundries, they're not going to be here, they're offshore and everything. Well, it is true. My grandfather started the company. There was, thousands of foundries, and you can start, and you can see even since 2000, we've had a drop. We all know somebody that's worked at a foundry that's closed, or, which is unfortunate, but we're really starting to see that level off. And, what we're starting to see is the value of those foundry shipments is starting to increase. So, as foundries find their niche and find what they're good at, and latch on to, technology to help advance them, we're starting to see that they're, able, the value of what they're producing is going up. I can't say for 100% fact, that's because of additive, but I think it leads to it. I think it lends to it, to the discussion. So I think we all just need to be aware of that and understand, what is our foundry really good at? What, can we use this technology to help advance us, so that OEMs, or, whatever product is being produced, it lends us to being a supplier to that OEM. And how can we use, whether it's 3D printing, or, other rapid, manufacturing, or more precise manufacturing methods, how can we use that in our organization, essentially to improve our value to the OEMs. So moving on, a lot of learning, long journey. This, like I said, started in 2015 with our first printer. Here, let's fast forward a couple of years. This is our second facility. We leased this space. Primarily what you're going to see is on the right-hand side here is our printing area. Some of this was packaging and storage, but this was this was when we got our second machine. So this area, as you can see, very laid out, had a lot of, packaging, clean, chemicals, I mean, it was laid out, for, our sand storage, for the day and for the week was there. But in a really quick time, you're going to see that was 2019 that we moved into that space. And as I mentioned, this is pretty much the print room. Like I said, we had you'll see now, it was filled with printers, but we had some of our packaging return, and then a lot of this space up here was not ours. This was kind of a mixed use leased space. But you can see from 2019, when we moved our second printer in, because we outgrew the first facility, we moved our second machine in 2019. Fast forward to 2022, let's go through here and count. We had 2, 4, 5 in this bay, 6, 7, 8, 9, 10. So at that time we had 10 printers in that building, and that was going from 2019 to 2022. So you can see how there has been an incredible amount of growth in just a very, very short time in additive manufacturing. We grew organically. We didn't have large investment. I will talk about it, but we have several printers that are managed assets, so they're not all Humtown owned. But we had to really pace our growth, because there was times when there was more work than we had printers for. We were on 24/7, actually 24/6. 7 day on Sunday is usually what's always optional. It's not mandatory. But the printers run. So we had people leave, at midnight essentially on Saturday, got all the printers running. Sometimes we'll have people that volunteer to come in on Sunday to keep the printers clean and moving, but they can run basically 18 to 20 hours. So they would just get them all running when they left. And then when they came in Monday morning, they're basically all ready to empty. But still, I mean, this was a very rapid growth of this technology. So in 2022, like I said, there's a couple of slides here I need to get more updated, but we had 10 machines in there. Now we have 12 machines, so it's gone up a little bit. But I mean, we were going through 4 rail car of sand per month, 500 tons of sand, which is absolutely incredible. And this is not just for prototype anymore. This is serial production, and we're starting to see all the stories. If you listen to some other webinars and come to some of the AFS committee, Grady and some of the other WPACA, they're putting machines in and they're running production. So as I mentioned, we're along this journey. We've added since 2022. We've added a couple more machines. We have a couple more coming. So we did finally decide. We said, okay, we're releasing that space. A space became available, and it had air conditioning, which is when you're running this process. Any of you that have 3D printers know this production, the process is really, really stable when you have good constant humidity and good constant temperatures. So finally found a facility that became available for purchase. So we ended up procuring this building. It has roughly 80,000 square feet of production and office space. So we have room to grow and to add printers. But we've also realized that we'll probably we'll hit a cap for what we can do in this area. And then we'll probably need to get printers closer to point of need where some of our clients are. So, but this is our new home. We just had an AFS tour there. We have the 12th machine is in. We're waiting on some parts to get it up and running, but we do have the machines all installed, all in place, wired in. Everything's ready to go. We're currently painting the floor. This was formerly a Gorence chocolate building, so there are still 3-inch lines of chocolate that they shut the boilers off. So, but it was air conditioned for that purpose, and the employees are very happy about that. As well as the machines in the process. But we had a great tour. Everybody that came through was very impressed. But we're still finishing up moving in. We literally moved the last machine in just a month or so ago. So we're still kind of new. We had to do some painting, and like I said, we're still painting the floors and getting it cleaned up. But invite you to come and visit us, and and we'll show you where we're at on our journey and how we can help. But we're very happy for that. This cell was set up and operational in our other facility. It's been moved over, and we're working on setting it up. But what do you expect to see moving forward as you go on this journey into additive manufacturing for serial production? We're really focused on robotic cleaning. Some of these jobs, as I mentioned, we're up to 80,000-90,000 EAU of parts, and that's a lot of pieces for people to have to manually reach in, grab, clean, inspect, put on. So what we're starting out doing is we have 2 job boxes per machine. The robot can shuttle back and forth. It will vacuum the parts, pick the parts, and then put them on this conveyor, roughly 80-90% cleaned. And then, so it does reduce a lot of the labor, and it does that all automated with vision. So we had this cell, we brought it in, had it all set up, caged in, we did our runoff. Very, 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 very happy that it worked, because, a lot of integrations and things, they don't always go smooth, but, and, there was a lot of room for improvement. We've actually come up with a few ideas just by doing the initial runoff. But we have a blow off box where it would, the air would blow off some of the sand and, do partial clean of the cores, and then it would set it on that green conveyor in the back. But it went in, prior to this video, I didn't catch it, but it actually went in and vacuumed enough of the part so that, it could see where they are, because it knows where they're all at in CAD. So, but anyways, this is one of the things that we're looking at. The other is, inspection. As we're doing more and more, higher profile work, we're constantly being asked, inspection, what are we doing? So we're working with, we don't have this yet. This was a company that came in, and we were doing an inspection. It was doing a color map overlay scan of the part. I've also worked with some CT, because we have a lot of really complex internal chambers. So we're working with them as well to see the internal. So these are some of the things that are up and coming. Like I said, we don't have this yet, but we know as we do get into more and more serial production inspection, we had castings at our customers that, they were running 100% CT. So we know as our customers have to up their, performance and inspection and reliability, we're going to have to do the same. So we're preparing. But, one of the biggest things that I've, as I've worked with clients, as I mentioned, we have 4 machines that are managed assets. One's for a university, 3 of the other ones are all OEM. So we print and we ship to wherever they need it. It can be, Foundry XYZ or Foundry ABC. And, we take their cores, we print them, and we ship them to their location. There's a lot more to additive manufacturing and 3D printing in the foundry industry than just buying a machine. Equipment's great. You come into our facility, you're going to see them. They require maintenance just like every other core blower or core machine or molding machine you have in your foundry. But there's some differences. As I mentioned, the print head, you need to run it all the time. So if this asset needs to be used, but you're only using it once a month, it's going to be very problematic when you're running binder through these orifices smaller than the human hair. So, we had OEMs that wanted the ability to have the quick response, but when they went to turn on the machine, they found out, oh, it's not going to run because the print head's clogged up and I can't get a print head in for a couple of weeks because it's shipped from another country, maybe in Europe. So, it was very problematic. So what they did was they said, okay, instead of us placing it in our location where we're only going to use it once a month, they actually moved it. We helped them facilitate, taking it down, putting it on a truck, driving it to our facility. We get it up and we get it running, do any maintenance that needs to get it running. And then, now we produce for them. And then, whenever they're not using it, they always get first use. We take that unused capacity and we help them, by running it and by selling that unused capacity. So it's basically a net jet model. Most people, understand, that the jets are very expensive pieces of equipment and they need to be flying all the time. So it's a very similar model to net jet. So you own the asset and whatever, other people use it, you basically get compensated for that time. But when you need that jet or you need that 3D printer, you call up, your parts are getting printed within 24 hours. So I always tell people, when you're on this journey, you may need a partner, not a printer. So, when you start the journey, buying that printer, may actually be more of a problem than it is a solution. We have seen many of our partner or our customers that have become partners. They stumble because it takes, you need to understand and, crawl, walk, run. So make sure you're using additive manufacturing a lot before you buy a printer, and, go into your service provider. I don't care if it's us or someone else, but really understand the process and what it takes and how, the flow. And like I was just talking about the print head, how often are you going to be running this machine? Because, there are some hindrances, to having the machine on site, and, it takes time and it takes a person, even if you don't have something to print, you still have to run the printer and clean it and maintain it. So, that's one thing. And then, these machines need to run a lot. 24/7 is an exaggeration, but they run at their optimal, 24/7. And then, we carry a huge inventory of spare parts, not only for 3D printing, but also, core machines. So people need to take that into account because a lot of the parts are coming from Europe, so it takes a really long lead time. But once you have knowledge of it, that it's going to be a lot more rewarding for you. So what's out there? If you're on this journey, what are the opportunities? Well, we have, there's some large format printers out there. Some of them, most of them are coming from Germany right now. There's 2 major players in that space. So we help our customer understand, what's out there, what are the pros, what are the cons. Some of them, have 2 job boxes, some of them are 1 giant job box. Does that make sense? Or, if you're spending that kind of money, does it make sense to just buy 2 printers? And that way you can run one material on one and another material on the other one, or have redundancy. If you have a printer that has 2 job boxes or 1 huge job box, but the print head dies, now you're printing a whole lot of nothing. So, we guide and we help our customers and clients, we help them understand that, if and when they decide to take that journey on their own. We've set up machines, in the United States and Mexico. We've helped, OEMs and foundries, along that journey. And what we found is, they still work and rely on us because just like every other foundry, as you've seen in Humtown, we've been a core shop for, 60 years. So there's always overflow, there's always breakdowns, there's always, surge capacity, and we're there to help them. There is some other types of printers out there. There is this SMAX Flex. We've investigated that technology. We've decided not to go that route. It is available. I think I haven't heard if they're still selling that piece of equipment, but I've seen it at the shows, so I know it's out there. You've probably seen it at the shows. It's out there. It's a lower cost. They're trying to give access to every foundry, which I do believe every foundry will have a 3D printer of some variety, moving forward. With it being basically just a robot with a print head, and I did go up and see the technology. The print heads were very easy to change out, just one module. They showed us how to do that in a matter of minutes. So there were a lot of advancements in this. We've kind of not focused on it as much because we decided to go a different route. But it's out there. And if you have questions, I've spent a lot of time before X1 purchased them. It was called Viridis. I've spent a lot of time up there. I've spent a lot of time with people that have this piece of equipment. It has its purpose. But just make sure you understand, what the pros and what the cons are of that type of printing. Over at GIFA last GIFA show, what Voxeljet is doing it with BMW, and even X1 for that matter, what they're doing for BMW and production serial, automobile production head, it's incredible. Robotics, I didn't even put the video in here, but they have robotic cars moving job boxes from station to station for, they use inorganic systems. So, there might be some post curing, some microwave, some cleaning, robotic cleaning. It's incredible. So the options are out there, but as I mentioned, crawl, walk, run. We are a job shop, so we don't do, we don't have, even though we have some high running parts, we run them on multiple printers. We're not set up just to make heads or blocks for one customer all the time. But even us, we haven't invested in this yet because, we don't get a lot of contracts. So, crawl, walk, run, get a printer, use a printer, whoever it is, buy a lot of cores, then, get a single printer and then, phase into something like this. But it is out there, it is working. Just, do your due diligence. Lower cost machines, so we got bigger machines, we got faster machines, we got robotic machines. This was, lower cost machines. There's not many of these in the industry. I've heard of one, maybe in South America. China, we don't have a whole lot of information coming out of China other than, you go to the shows and, there's Chinese companies making 3D printers. So, very interesting technology. It's not, I've seen some of the features and it's not direct copy. What I always think of is, okay, they're just going to take a machine and some of them are, don't get me wrong, some of them are, but I've seen some of these technologies that are not direct copies and there are innovations being made. So, interesting, like I said, spend your time, understand what you're getting, and make sure, it's going to fit your need, in the foundry. So to kind of wrap all this journey up, what does the foundry of the future look like? I've been to Brembo, I've been to some really large foundries. I'll be the first to say, additive manufacturing is a great tool, but it will by far never replace casting. It will never replace all core making. When I see, the rotor cores pumping off of those machines every, so many seconds, I sit there and I say, I don't care how fast the 3D printer is, it's going to be light years before, and the geometry of a brake rotor is so simple, for production cars, why would we ever use additive manufacturing there? So patterns aren't going away, traditional molding, not going away, in my opinion. But what are we going to start to see? We're going to start to see more of this digital inventory. Almost every new job is being developed with CAD when it makes sense. A highly complex core, 3, 4, 5, 6 cores that need to be assembled. I'm going to start seeing those core assembly rooms go away, and we're going to start seeing the pattern and then this digital core coming into the foundry to get that casting. No doubt, that's already happening. Now, what I challenge foundries and what I see is foundries are in a really good opportunity right now to embrace, even direct metal printing parts. We've been looking at the technology for years. I don't think a lot of it's there yet, but there are, we call them cats and dogs in the industry, and I think there are certain parts, not flight critical, but they have a somewhat of a complexity. It takes a long time to get tooling. 3D printed molds and cores, are a solution for a lot of them. But seeing how fast and the cost of these 3D metal printers coming down, I will start seeing direct metal printed parts come in. Maybe for some of those cats and dogs, maybe a manifold or maybe a flange. Something that's not super critical. But why I say that is because foundries are uniquely positioned to have the ability, they understand metal, they have metallurgists, and so I understand that and the design and orientation for strength, et cetera. They also have a lot of the downstream post-processing in-house. So whether that's X-ray, dye pen, whatever type of inspection, the foundries already have that. So if they just take that part and they start looking at that part and seeing where did it fail, or where is it, are the issues, I think it's an opportunity, not a threat to foundries. And like I said, I'll be the first to say I don't think conventional molding or patterns are going anywhere. So I definitely don't think we'll ever see a day where everything's direct metal printed. So I don't know. This is being recorded. Somebody might be able to call me that on some day, but we'll see about that. But with that, I'm going to open it up. If there were any questions that Bo didn't get me to shut up while I was talking, he can ask them now. But I really appreciate everyone's time. We're available to answer questions. My email's there. Call me. Love to talk to you about your journey and where you're at and how Humtown can be part of the solution. So thank you so much.
Well, thanks, Brandon. Wonderful presentation. Great story. Really appreciate you telling that one to everyone.
Yeah, absolutely.
We didn't have any questions come in during your presentation, but we do have a couple in coming now.
Yep, I can see them now. Yep, I got them up now. So thank you. Are we currently reclaiming any of the sand? Sometimes. What we find is we have not put in a like a thermal reclamation system, because everything we print we're shipping out to the foundry. But on that vacuum stand, we are able to introduce that up to a certain percentage. But what we find is if you do that over and over again, you start to build your acid from that reclaim. So what we typically do is we'll take that reclaim on some, it depends on the part, big, large molds, that we'll use like up to like 30% reclaim of that vacuum sand. We are not actually like breaking down molds and thermally reclaiming. Some people are, but like I said, we don't have that much that it really makes that big of a difference. But it can be done. It is being done. But we only reclaim the vacuum sand. What type of tolerances can be held consistently? So plus or minus 0.5 millimeter is as advertised on the machine. That's pretty much what we stick to. We have jobs and in production that we've gotten down plus or minus 0.3 millimeter. It takes a little bit more orientation. You want to print them flat on the bottom of the build, so it may cost a little bit more, it may take a little more time. You may not be able to play Tetris in the job box, moving the parts around. They all need to be in the same orientation, but we have had projects plus or minus 0.3. So all right, Brian. Hey, Brian. Great partners. The evolution of print manufacturers going in the next few years. Do you think costs will improve? Unfortunately, I don't. We don't see the cost of the assets coming down, and as everything else with inflation and everything, it seems like the costs are going up. So I know, some of the manufacturers were trying like the robotic printing to try to bring that in and lower the cost of printing, which is what we need to be like a force function change in printing. Like we need some of those Asian machines that are lower cost to be. The biggest thing is getting them over here and having service and parts and all that. But if we can get a lower cost machine made anywhere, whether it's the U.S. or Germany or China or other countries, it needs to be repeatable. It needs to be reliable. We need to have parts and service. We do a lot of the maintenance on these machines ourselves. We basically go in and not only change out parts, but sometimes we have to source local parts because some of the things are 4 or 5 weeks, 6 weeks backlogged coming from Europe, and we just can't be down that long. So unfortunately, I haven't seen a lot of to the other point of that, I don't see a lot of innovation. The same S-Max serial number 13 that we have versus machine 200 and some. There's been changes, but it's not been anything that's actually affected the price of printing. These machines are not 2 or 3 times faster than they were 15 years ago. They're basically, essentially the same machine. So we need to see some innovation. We need some investment. A lot of the print companies have been struggling, but unfortunately, I haven't seen anything yet that will drive the cost of printing down, whether it's a lower cost of machine yet that's been in the industry or innovation that's making the machines 2 or 3 times faster with an accuracy that's acceptable. So, but great question. Brazil, absolutely. I'm actually speaking. Thank you for your comment. I'm actually speaking at an event, I think in November. So thank you. Yes, I've been to Brazil several times. We ship to Brazil. Would love, the opportunity. If there's enough business down there. We are actually partnering with a company in Europe, in Germany. We actually have a machine being installed, and we are doing printing with that partner. In EU. So that opportunity came about. So we are definitely open, to different markets, and in Brazil would definitely be one that we would love to. So, and yes, the partner is what we did in Europe. That would also work very well in Brazil. Thank you. Jacob, we can talk offline, but to see exactly, I mean, there is a lot of overhead, mainly in our own, doing our own maintenance, to keep these machines operationally available. Reach out, shoot me a note. We can talk about that more offline, but there is significant overhead. You're going to need, it depends. Every situation is unique. So if you already have CAD modeling, CAD designers, people that understand all that, it's one thing, because they can pick up some of the burden. But if you are going from basically just a traditional, air set green sand mold line, running a Redford core blower or a shell machine, and you want to get into it, then it's a lot more investment. So I'd like to talk to you offline about that, just because every situation, and we only have a few more minutes, but great question. And that's why I always tell people crawl, walk, run, start using prints on the outside, see how that works out for you, and then go in to your supplier. If they're a good supplier, they're going to let you in and help you along the journey. They're not going to say, oh no, you can't come and watch us, or see how long it takes to clean a job box, or any of those things. I mean, we'll bring you in, put you to work. You can see your parts print, clean. One of our customers, they were going to either put a machine at our facility or in their own. I had them send in all their team members for a week to make that determination themselves. I can tell you, oh yeah, bring it to Humtown. We'll help run it for you and everything. Well, I said, you make the determination. Come in and work, and see what this process really entails. So, but great question. Bo, I think we're coming up on our hard stop, but if anybody has one last one, maybe I can get it in.
Yeah, definitely. Is there any other questions for Brandon? His contact information is on the screen right now. So if you don't have anything for him right now, but have something later, feel free to reach out to him.
Absolutely. Thank you everyone for your attention. Bo, as always, thank you for hosting. You did a great job. You always do. Thanks to the AFS. Great organization, helping to promote. And all of you, I invite you to join the AFS Additive Manufacturing Committee. If you have any questions on that, email me. I'll get you in touch with Kelly Kearns or some of the, whatever division, committee. We'd love to have you. Love to, and even if you don't using it yet, come and start learning and participate.
Well, thanks again, Brandon, and thanks for being on this webinar and sponsoring it today.
Absolutely. Take care, everyone. Have a great day.